portfolio project for myself. Hello everyone, I am Saurabh Kumar and I'm creating this video to showcase my data engineering skills and create a portfolio project in which I am going to extract, transform and load the data. The overview or the plot of this project is to compare the forest area land reduction with respect to the population explosion we are currently facing. So I am accessing the data from a World Bank website where there are different indicators. I'm using this forest area in square kilometers data, and the data files are present in CSV, XML and Excel format. Then I'm also downloading data for population, and I am using different files for male and female population. In this website, uh, it's taking some time to load. I just want to show right. So there was an option to download the file for total population, but I'm trying to take female and male population differently so that for BI reporting we can make a comparison both of them as well. So there are three files, one for the forest area, second one is the female population, and third one is for the male population. And now if I uh, define the outline of this project, it is we are going to ingest data using the HTTP connector. We'll directly access the data from that website. We'll ingest data using parameters. We'll save the file using parameters, and this complete pipeline will be fully automatic. Even for the parameters, I don't have to provide values manually. After this, once the pipeline is successfully run and we have the files, we have the data in our desired data lake location, what we are going to perform some transformations in order to uh, get this data in a desired format as required for the BI reporting. For the transformation part, what transformations we are going to make, I'll define them at the time once the pipeline is run successfully and we have the data. There's a catch that while accessing the data from a World Bank website, files are not directly downloaded. They come in the form of zip folder, compressed files. So in pipeline, I cannot directly access the zip file or extract the files from there. So what I have done is I have downloaded these files and I have stored them in my GitHub repository under the name female.csv, forest.csv and male.csv. Now, as I am in the female.csv part, this is the web URL, and what I am doing is I have created a JSON file in which I have provided this relative URL. This relative URL is nothing but this part of the link and the file name. And as I told that this pipeline will be fully automatic, we will be defining a lookup activity which will fetch the relative URL and file name from from this JSON document and provide it to in the pipeline automatically. So let's start creating our JSON pipeline and ingest the data from my GitHub repository using the HTTP server, HTTP connector. Sorry, I'm fumbling. So let's start by building our first pipeline. Also, I have downloaded this JSON file by writing this in JSON format, and I have stored it in my metadata folder. Here it is, data.json. And if I preview this file simply stores the relative URL, the file name for all three files. Now I'm talking about relative URL. What is the primary URL or basic URL? It is nothing but simply this part, https:/github.com. So let's start our first pipeline. I'll give this pipeline name as ingest data, ingest forest. Try to keep it in completely small letters. Population data. So as I have told that we are accessing this data from HTTP connector from the website. First, we'll define a lookup activity, and then once there will be a copy activity, the source will be defined using the HTTP connector. But first, let's access the relative URL and the file names with the lookup activity. I'm sorry. So this is the lookup activity, and we'll give this a name, lookup JSON. We can close it. Now it is asking for uh, source dataset. It seems I have created one dataset, but we'll define a new one while working on this project. As the file is stored in data lake gen 2, which is a default data lake attached to the Synapse workspace. We'll do it. The file is in JSON format. We are creating DS. So while creating dataset or linked services, there can be any naming convention whichever suits you well or whichever is used in a particular organization. But as I am working on my portfolio project personally, I'll define it according to me so that I can understand while working on this project and different components of the pipeline. So DS stands for dataset, and what I am doing is DS JSON lookup data. And as with Synapse Workspace, default data lake is attached with it. So with the default data lake, default link services are also created. I will give the path of that JSON document. Here is a file data.json, and now it's done. We have created our dataset. All right. We'll uncheck this first row only because we need all the data. So if let's preview the data. So it is giving us the relative URL and file name of every file stored, every document. Now, as we have the lookup activity here, and it is providing us with the relative and uh, file name, we'll iterate it using the for each activity, which part by part provide the relative URL to copy activity later, and that copy activity will fetch the data from GitHub repository and copy it to the desired data lake location. So let's bring our iterator. We can search for each. Let's connect it. Now for each. Uh, we can click as a sequential because it does not affect anything. Now the main part is first of all naming convention. We can give any name that for each file. Okay. Now settings. What I am going to retrieve from the lookup activity, basis on which for each will iterate. So this is lookup JSON activity output, and after the output I will put value. Now you must be means whoever is experienced must be knowing, but if you are new to this data engineering part, data transformation and Azure, I must tell you from where this value came from. Let me save it like as it is, and I'll tell you how I put that value. Let's click. We'll run this file till the lookup activity. By clicking this red dot, I am asking the pipeline to run till lookup activity and not further. Let's debug it, and I'll show you why I wrote there that value thing. So as the file is succeeded, let's see the output. This icon shows the input and this icon shows the output. So it gives us the count. There are three dictionaries which contains the relative URL and file name, and this value here, it contains that list of dictionaries. So to access these relative and file name later on, first I am accessing this value part. So now for each will receive everything from this value part only, which means from this bracket, square bracket, to this square bracket, it will iterate upon different dictionaries. Let's unblock it. All right, so as we have the values here, now let's proceed with the for the main part. I'm sorry if I'm fumbling, but let's create. What we are going to do, we are simply going to copy data. Now here we'll create the HTTP connector, where I will tell you how to use the parameter with the URL part and the sync file name part. We can give it a name, copy data HTTP to data lake, and also let's mention which data: forest population data is active. Everything can be left as it is. Now it's time to create a data set. So from where we are going to fetch the data? HTTP website. So we are creating our HTTP dataset. The file is in CSV format, ds uh, forest population HTTP. Now linked services. I guess we have created this, but I'll do it once again for you. ls forest population data ingest. Now base URL. Here I'll use it https double slash github.com, and that's it. Authentication type could be anonymous as of now, and that's all. So right here we are not getting the option for um, the relative URL, but once the data set is created, we have the option to provide the parameters for the base relative URL. We have created our data set, linked services. Here is the relative URL, but in the relative URL we are not getting any option to input any parameter here. Let's click OK. and I'll show you how it can be done. So this is the data set. Let's open it. Here we are getting the option for parameter, and I'll tell you how we can do this. Parameter relative URL, and that's it. Now I can just use this relative URL here. So we have set a value for a relative URL part that it should be used using a parameter. And now we'll connect the parameter to that for each activity output. So it's uh, first row is header, everything is fine. Let's jump to a pipeline. Here, now we are getting the option for relative URL parameter. It's asking for the value. I will give it using the for each item dot. Now let me show you. While saving this JSON document, I give the key as a relative for the relative URL part, and file name is the key for file name .csv. So while accessing this relative URL, I have to give relative item dot relative because it is coming from the for each activity. It's done. It's set. Request method get additional all set. Sync. We'll create a sync dataset again, and here we are going to store these data in our data lake storage in a CSV format. DS uh, wait a minute. I'm sorry, but my father came and I have to attend him first. So let's start. Let's start from where we left. So we are creating a data set. DS sync to sync forest population to data lake. Link services, as I told, by default we have a link service to our data lake. And now it is asking where we should store our files. So we'll give it here, World Bank. So again, when for the file name, I'm not getting the option to input a parameter here. So no worries, we'll get it done once the data set is created. It is created. Let's open it. Now we have the option to add dynamic content here. Let's create a parameter, file name. Now input the file name here. All right, we have set a parameter value. Now connect this parameter to a pipeline. We are getting the option here, file name for each item dot file name. As I told, this is the key value, file name, all set. So a source is set, sync is done. We don't need to set any mapping here, settings, nothing. Everything is set. We can go back and reset our, let's validate our pipeline. Pipeline is validated. Let's publish everything, all changes what we have done. Yes, it's done. Till it's working, it's publishing. What we can do is we have the data here, female.csv, forest.csv. I am going to delete them so that new files can arrive. Publishing is completed. Let's delete these files. All right. So now our World Bank data folder is empty. Container, as we can say. So let's. So as the validation is completed, we have published a pipeline. Let's debug this complete pipeline so that we can achieve what we were trying. We are trying to extract the data from my GitHub repository to the data lake using parameterized pipeline, which will automatically fetch the relative URL and the sync file names and provide it to the copy activity. So let's debug it. It's been so long. My parents visited, so they came over to our place and they were playing with my little 1-year-old daughter, and they just came back. So I uh, got there to attend them. So sorry. So first copy activity is succeeded, second is also succeeded, and third one is running, which means the pipeline is working as intended. So all activities have been completed. Now let's move to our data lake, World Bank data, and here we are. We have all three files. But now again there is a catch, which means these are not actually files. I just did this to demonstrate that how we can actually fetch the data using HTTP connector from any website if the data is available openly or publicly. So I'm sorry again, just got distracted from the cute little baby's activity. She was thumping on my door. So let's begin from where we left. So although a pipeline ran successfully, it copied the content from the GitHub repository, but the pipeline ran successfully, it depicts that the files were copied, but not actual files were copied from GitHub repository. Because as I can show you that this URL does not provide any download option. It is just a URL to reach that file. This is just a path. However, I did this activity or this pipeline just to demonstrate how we can use HTTP connector to access data from any website if it is giving a direct option. So what this file actually contains is some HTML content which is not of our use. What I'm going to do is I am simply going to delete these files and then upload them manually. This was all done just to demonstrate the usefulness of HTTP connector. Here are our files. Let's upload them. So we have our files uploaded. Now when we preview, we have the population, female population according to the years. Okay, so we are done with the pipeline part. Our pipeline ran successfully. Everything uh, with the relative URL, parameterized pipeline, fully automatic. As you have seen that we not at not even at one instant we input any manual URL or the file name. It was completely automatic using parameters to fetch the details from a JSON document using a lookup activity. So now as it's done, now what is the second part is to transform this data, and how we are going to transform it. And this untransformed data is stored in my World Bank data. I'm going to create another container here which will contain the actual clean data which can be used for further BI reporting. We can create a new folder with the same name, World Bank Forest Population Cleaned. Create. So we'll store the data after transformation into this location. Alright. So let's first understand what transformations I'm going to make. And in order to do that, let me first show you what files do we contain. What data in the files do we have? I'm opening the forest area file, which have I do not have the licensed version of Microsoft, so using WPS. So we have the country name, 3-digit country code, indicator name, forest area, and it's all common. This is also common. Now we do not have data from 1960 till 1989, and from 1990 we have the data till 2020. Now, um, so the transformations. We'll be working on the data from 2010 to 2020. We'll filter the data from 2010 to 2020. Then we'll filter the data for India only. We'll be comparing Indian forest area reduction with respect to its population. We'll unpivot the data whenever it's required. We'll create join operation to merge all these three files together, which and a single file will contain the forest area, the population of male and the female population, and then sync it to the ADLS location. So this transformation will be having 4 to 5 activities altogether, and which contains major activities such as join, unpivot, pivot, filter operation, select operation. Let's start creating with that. I'll first start with the forest. I use this Synapse Analytics workspace because it's easy to use. It integrates the data storage, the analytics part, the pipeline part all together. I do not have to move or jump from one portion of the Azure uh, portal to another. I can just start investigating or working on my data even from the one portal. So as I have selected the forest.csv file, I am directly getting an option that new data flow. I can click on this and fill some basic information. What do we call this in transformation? Uh, Forest population transformation. Need to create a data set here. TS forest. Format is delimited text. We can use from connection store and create. Alright, our source is fixed. Let's give it a name, forest. And this name do not uh, incorporate underscores or some special characters in the naming. So we just need to give it without any space or without any uh, underscore. Forest area, DS is here. We can allow schema drift, so that schema drift is if later on schema changes, we receive a file with even with one more column. This transformation source or pipeline will not uh, stop or will not fail. It will continue working. I have disabled sampling. Source options. You do not need to provide any wildcard parts because we have already done it. Now the best part is projection. Let me show what it does. Now using the projection, what we can do is we can detect the data type which we are receiving from the source, and we can change it, and we can change it right now even, but I'll tell you, but we cannot detect it. So for detecting and to work with the data flow easily, we need to uh, allow the enable data flow debug. This data flow debug will run a cluster, Spark cluster on this whole transformation will run. So I have enabled this and showing debug time to live 1 hour, which means if I left this workspace right now, so 1 hour is the inactivity time, and after 1 hour of inactivity, this cluster will automatically terminate, which means it will save our money, and that's the best feature, and that's a good feature Microsoft Azure provides. Means I do not have to pay additional charges for the mistake I commit. Microsoft will take care of that. I click OK, and now data flow is creating a cluster, and this cluster approximately takes 2 to 3 minutes or 4 to 5 minutes in some scenarios. So I'm pausing the video here and will resume it. So now as our cluster is up and running, we can perform activities now. We can add different transformations, and we can see the output or the projection what that activity is going to perform or going to highlight as a result. So we are going to projection type, and now I am going to detect the data type which will come from the schema. And to detect this data type, now this option is available. Earlier it was not. As the cluster is up and running, it will perform the detecting. Let's wait for it. So it has successfully detected, and as of now, country name is string, country code string, indicator name, indicator code, all is string. No worries. Let's so till now the data is showing as a string for till from 1960 to 1970 because it's null. There is no data in it, and since 1989, 1990, we are getting the data type as double. Again, 2021 and 22, the there was no data, as you can see. 21, 22 is empty, so it is showing as string. We do not have to worry about it. We just need data from 2010 to 2020, and it is in the correct format, double. All right, so let's we can even see the data preview here because a cluster is up and running. Sorry. Usually it takes time always. So we have the data, everything null till 1989. From 1990 we have the data. Good. So now uh, we have two options. Either we can first select the data from 2010 to 2020, or we can first filter the data and then select it. According to me, I think filter option will be good because it will reduce the data size, and for further transformation a cluster will have to do less work. So let's filter it out at the very first point. I'm going to write a filter activity here. Let's all right. So we have the 67 columns from here, and we have the 67 columns. Here I will give the name filter India forest area. Filter on. Now this is the expression builder where we can define a condition. As in SQL, we do select this data, the columns from this table, and where. Now in the where clause we use condition. So this expression builder is simply like a where clause. Okay, we are opening the expression builder. So we can give on the country name we can filter it. Country name is double equals to in quotes India. Save and finish. Now if I preview the data, I must receive the data for India only. Columns will be 67, but great, we are getting data only for India. Now I can use the select transformation and we'll be selecting the data from 2010 2020. Select 2010 to 2020. Sorry, 2020. Great. So now it is showing as filter India forest areas column. This is nothing. What I'll do, convert to fixed mapping. And what it will do, due to large number of input columns, what is showing, a rule-based mapping is used because as the number of columns is large, there we have 67 columns. So it has it is using by default the rule-based mapping, but I will convert it to the fixed mapping so that I can choose the columns according to my need. So as I clicked on the fixed mapping, I am getting the options. I will do this. I select all columns and now I am extracting those columns which I need and I'll delete the rest. I need only country, sorry, I need country name and then just directly hop on to 2010, 11, 12, 13, 14, 15, 16, 17, 19 and 20. That's it. Rest others are selected. We can delete them from here. So we are left with only, I guess, 12 columns. Yeah, 11 for the values and one for the country name. I'm just keeping the country name just to that sorry for the India purpose that this data is for the India. Skip duplicate input columns, duplicate output columns. We do not have the duplicate columns at all. Now the data preview part. Let's see the data preview whether select transformation uh, ran successfully on this data or not. Exactly. 2010, 11, 12, this much. Now here we can say 67 to columns and here we have only 12 columns. Great. Now you see this data is in a row format. It's just flat. But what I need to perform or join the different files together is to put them in a columnar format. It means these years should be 2010, 11. Should these 2010, 11, 12 must be unique row or the primary key in SQL, as you understand, and these values must be the appropriate values adjacent to it. How we can do it right now, as you see, if you just understand or imagine that that columnar format is our ideal format, so this is a pivoted form. So to convert this pivoted form to the columnar form, I'll have to just unpivot it. So I'm going to use unpivot activity. I'm unpivoting it. Unpivot forest. I am not giving any underscore. Yes, I am not giving any underscore or space in the names. Great. Ungroup by, keep it as a country name. So the country name will be just common for all the fields. Unpivot key. Unpivot column name. So what the that column names should be, I'm giving it year. I'll keep it all small. And now unpivot column type. This is very important to this column type means the data type. So let's find out what our data type is. what data type we are getting from here. Let's check it. Projection. We are having the double as the data type, so we have to use the same data type here, double. The column names as values are done. So that 11, 12, 2010, 11, 12, 11, those will be the values for the year column. Now unpivoted columns. We'll just keep it to the normal. Drop rows with null. We can select it, and we need to do is we can select a column direct from here. We can just give a column name, and it will be double. That's it. So what we do, we group it using the country name. For the unpivot key, I'm using the year with the data type double, and unpivoted columns. Those are the column. It is asking for the column names, which must be unpivoted, and what the name that column must have. So I'm giving my specific or my particular name, the forest area, with the type double. So it's time to preview the data. Let's refresh. Great. Voila, as they say, India 2010, 11, 12, we have everything in a columnar format. Great. Now we have done this for the forest area file. I would say I'll pause this video here and I'll just uh, repeat all these four activities for the female and male files. And these all transformation are similar there as well. So I'll just resume this video once I reach to the unpivoted part, because uh, uh, recording the repeated activities will just increase the length of this video and didn't show something uh, new, doesn't show depicts any new thing which I am doing here. So I'm just pausing it and I'll resume it back. All right, so uh, transformations are complete for female and male population files as well. We have unpivoted the data. This is the male population, the last file, and you can see after unpivot, the data looks similar to the forest area and female population file. I did this to achieve a joining operation. We can join forest population, the female population, the male population based on the year column matching. So let's start with our first joining operation between the forest area and the female population. Basically, we have to combine all these three files with two joining operations. First, we'll join the forest population file with the female population file, and after that, that combined file with the male population file. So let's start with the join operation. Join. This is join one. We can name it join. Join forest and female population. Now, these are the options we have. Left stream is the unpivot forest population, and provide name contains invalid characters only alpha. Oh, sorry, I just by mistake pressed the spacebar key. So the left stream is the unpivot forest population, and the right stream will be unpivot female population. It will be an inner join, and we are joining on the basis of year, because country name are all similar. It does not. Yeah, all done. So let me show you. uh, Left stream first population, right stream unpivoted female population. We are performing an inner join here with the join conditions on year double equals to year. We have to match the year. Now the data preview. Great. So we have country name columns from both the data file, both the files, both year columns and forest area and female population. We have successfully performed a join activity on the forest area and the female population part. Now, what I can do is I can create one more join and directly join the male population with the same. However, uh, I can use the select operation first to remove the duplicate columns, but if I do that, I have to uh, use another select activity. Basically, while creating the transformations, we have to keep in mind to create a robust pipeline, but at the same time, it should be easy and uh, do not have such complex transformations, or if uh, which is called tuning data flow, tuning a pipeline. uh, we have to create it as easy as possible. So uh, uh, instead of using two select statements, I should use one select after joining all the files. So I am using another join operation here. Let's join it. Okay, join again with male population. Left stream join forest and female population. Right stream will be unpivoted male population, which we received from here. Unpivoted unpiv male population. So I'm performing a join inner operation. Again, the columns we are using is, wait, there's less space. That's the only thing. Unpaved forest population area. All right. So as two columns have been joined, what it is showing is we have two year columns. So in SQL, as we do a table A dot column name, if we have similar column names, and table B dot that column name. So that's the same is happening. We are getting for year we are getting two options. One is from the unpaved forest population, which is the stream for forest, and one from the male part. So I can use either one. I just use, and one is the male population year. Great. So let's see and the data preview. All right. So we have duplicate columns. We have three times the country name, three times the year. But what the main thing we have is forest area, female population, male population, which proves that a join operation is successful according to the years. We have the correct data in the correct format. Now, what we can do is we will simply use a select operation using which we can remove the duplicate columns. I guess due to my internet speed, things are lagging, but no worries. We have the option now. Select. All right. So Now this we can do is create optimized data. Because we have combined data, I'm just giving it a name. You can give it any names. So as you know, skip duplicate input columns, skip duplicate output columns. So we have 9 mappings here. Country name, year, forest area, country name, year, female. If I see the data preview, let's see what it's giving. I haven't done anything on my own. I haven't deleted anything. We have just selected the um, yeah. We have just selected the default settings. Skip duplicate input columns. Skip duplicate output columns. So as of now, there are 9 columns. 3 country names, 3 years, and then forest area, female population, male population. But when we see the data preview, as the options were active, we are left with 1, 2, 3, 4, and 5 columns. Now, I can even delete this country column, but let's leave it as it is. Data transformation is completed. Now, the only part we are left with is provide a sync location. Just give it a sync. Great. We have the sync file here. Sync settings. We'll give it a name. Sync to ADLS forest population data. A name could be anything as long as you need it to get a clear context. Optimized data is the stream integration data set. I should create one data set. We are just using Gen2 CSV format. Ds sync transformed forest population data to where data lake link service by the default link service. And yes, now I must give it a file path. We are giving a cleaned data set. All right, usually a file name, I can give it a file name, uh, um, forest population comparison data.csv. We can write CSV as it, or we can just skip it. It will automatically give it an extension. Import first row as header, import schema, everything is fine. We have created our data set for the sync. What it's say? Okay, just leave it as it is. Now let's see. All right, it's done. Data set is, it is a data set. All right, it could no, I don't think. Testing connection, everything seems fine. Skip line count, nothing. Settings, clear the folder is by default clear, but if we check this, it will first delete the existing files and then copy the then sync the data. File name option, pattern per default, no, we will not do it right here. Let it, give it up by default names. Link service, uh, nothing to do right here. Skip duplicate, right. Optimize just for the partitioning purpose to auto tune the data. Let's refresh and check the data preview. Wow, it's working great. So I guess our transformations is complete. We should publish this. and we should run it using the pipeline using a trigger. Publish. Let me publish everything. Great, it's published. So that the changes we have made, the new transformations we have created could be saved as a genuine transformation. If I do not publish, it will just the efforts will go waste. So I guess publishing is deploying changes to a workspace. Now we will get an option. So publishing is complete. I'll jump to pipeline. I I need a new pipeline, and using I can use it data flow transform forest population data. Alright, it's the name active settings data flow forest population transformation. Compute size I'll keep it small. Logging level I do not want to log any logging means the metadata gets logged to a file, but I do not want to do it at this point. Sorry, sync run parallel nothing. Staging, no, there's no parameters we have to give. All right, so let's validate the pipeline. It is validated. uh, there's nothing, no option to do. I'm getting this one here. All right, no worries. Let's run this with using a manual trigger, triggering it now. Alright, it's asking me to publish it. Let's publish pipeline 1. I haven't I have checked everything, and yeah, this one usually shows for some error, but I haven't provided any parameters here, so it should not do this. I don't know why it's also fumbling like me. So alright, so let's add a manual trigger now. Great. We can monitor our pipeline using the monitor section. Pipeline is up and running. We can refresh. It's in progress. I am pausing this video right now. Once it's successfully completed, we'll just check the whether we have the transform file or not. So I just refreshed it and the pipeline ran successfully. It's 8:52. I left this pipeline. I triggered this pipeline on 8:48, so it approximately took 3 to 4 minutes. And now let's go to our data source location and see if we have that transformed file or not, because then only we'll consider this project as successful. Okay, so we selected this World Bank Forest Population Clean dataset, and success, we have this file. The name is by default given by the partition. Let's preview this file. All right, so we have the country name, we have the year, the forest area in square kilometers. As we know that we can give this detail in the metadata as well, the female population and the male population. So in this project, we extracted the data using HTTPS connector. I demonstrated how we can extract the data using HTTP connector. If we have the file stored in blob storage containers or data lake, that it can easily be extracted, but I wanted to showcase that part as well. So I just make that up. I uh, what I uploaded the files on my GitHub repository and tried to access that using the HTTP connector. But those were just the path to the file, not actual files. So we get the HTML content. We deleted those files. We uploaded the files manually in our data lake storage, and then we started creating uh, the, the data flows. What we have done, we selected the columns from 2010 to 2020. We filtered the data for India. We unpivoted the data to get it into a columnar format. Then we merged the files using join operations twice to join three files. And then we use one select activity to just eliminate the duplicate columns for year and country name. And then we just use a sync activity to sync it to a desired data lake gen2 storage location. So now with the preview, as the file is we have the data in optimized format according to our need, according to our project. Now if we do a BI reporting, we can create a time series using the year and and plot forest area trend lines of female population trend and male area population trend line. We can compare the trends between female and male population over these 10 11 years of time period. We can do anything according to our need, according to our project requirements. That's my daughter. She's just playing. Ignore it. uh, so uh, all done. uh, Sorry, I need to pause this video. Basically, I was focusing on this project and she started eating her wax color. So, um, I know we had different disturbance in the between, but uh, I just got 2 days from a working schedule. I'm working 10 hours shift. Traveling includes 2 hours to and fro, which approximately uh, aggregates to 60 hours a week, and I just get 2 days as my week off. So I'm just trying to create this project, showcase my skills, and inform recruiters that I can do certain tasks. I started, but I can do even much better. I have developed this interest. This is my interest. I love this work. So uh, things will happen as they are intended or as they are destined. So yeah, let's come back to our project. We have the file as defined as per the project requirements. We have the year in the columns. We have the forest area, female population, and male population. We have the desired format of file as CSV. Now, any BI analyst, or if I receive the task to create reports, I can just access it using Tableau, Power BI, and create reports between comparison between forest area and total population, female population with male population, and time series data, and anything can be done. So I just repeat again, we extracted the data from using HTTP connector using from a website. I demonstrated it, not actually done. I just demonstrated in this video how we can do that. And uploaded the files manually because we were not from the website. We are getting a zip folder, and from GitHub we were just getting the path to the file. I didn't have the option to upload a file somewhere from where I can directly use the HTTP connector, so I just did this to demonstrate. Then we transformed the data, we performed different activities, we merged the data, we unpivoted it, we selected the columns, we detected the correct data type. Uh, on this transformation runs on the cluster, a PySpark cluster in behind the scenes, as you can see. And then After transformation, we loaded this data to our default data lake Gen 2 storage, and this is the file format right now. I believe my extract, transform, and load operations are completed as per the specifications of project I have designed. And that's all. If and there's no point to say if you like subscribe and nothing else. I'm not doing it for that purpose. I am just doing it to showcase my skills. So thank you so much for watching this, and yeah, you can comment your feedbacks because they are the most valuable part, and they can provide me even more learning. They can highlight the areas where I need improvement. So yes, please comment on them, and thank you so much.